Hello and welcome to Algebra 2 tutorial. We are still looking at transformations, but this time we're going to take a closer look at transformations and equations. So can we write the equation of a certain transformation? And then there's going to be three ways we look at that with going from a graph to an equation, and then can we take an equation and go to a description? And then can we take a description and then write the equation from that description? And we're going to focus on absolute value equations. So let's take a look at how that works with absolute value equations first. So our absolute value equation is y equals, and if we put all the stuff in it, there's an a first, so there could be a number in front, x minus h. There could be a number inside the absolute value with the x, and then a number at the end that is also either adding or subtracting. And each of those three letters, A, H, and K, do different things to the graph. They transform it somehow. So let's take a look at how they can transform our absolute value graph. So here is a nice absolute value graph in GeoGebra. And you can see we have our equation A, H, and K. So what happens if we change those numbers? So right now our A value is a 1. What happens if we take that A value and make it bigger? And then make it smaller? I'm hoping you can see that that is a vertical stretch. If A gets bigger, it gets stretched up. If it gets smaller, it gets stretched down and flattened like a pancake. So if A becomes a bigger number, we get stretched vertically. If A gets smaller, we are shrunk vertically. So that's our stretch and shrink is letter A. All right, now the K value. What does adding or subtracting a number at the end do? Well, if K is a bigger number, the V goes up. And if K becomes a negative number, the V goes down. So that is a slide, which we call translation. And because we're going up and down, we call that a vertical translation. So a positive number means we go up, and a negative number means we go down. Let's put that back in the middle there. So the K is our vertical translation, up and down. All right, now H. What does H do? If we have a number on the inside. Oops. So you can see that is a translation. We're again sliding, but this time we're sliding side to side. Now this one, hopefully that makes sense, but it has one tricky bit. Do you see how it goes opposite what you might think it would do? A negative number actually moves us to the right, and a positive number moves us to the left. That's the tricky thing to remember about H, is it behaves the opposite the way you think it does. K behaves nice and easily. A bigger number means you go up, a smaller number goes down. That's pretty intuitive. But H is slightly counterintuitive. If it's a positive number, we go to the left. If it's a negative number, we go to the right. So H is a little opposite working there. Something we have to remember. All right, one more thing I want to do with the A value. What if your A value switches sign? Right now, our A value is positive. If A becomes negative, you see how our V shape flipped upside down? It's been reflected over the x-axis. So your A value can be a number, certainly. I'll make it a nice big stretch. But it can either be stretched and then be reflected down if that A is negative. But if that A is positive, it's right side up. So your A kind of does two things. It does the stretch, but it can also reflect you over the x-axis. And it does that when A is negative. All right, so hopefully we've got a pretty good handle on that, on what A, H, and K do. Now we can put some numbers into it. So first, we're going to take a graph and then write an equation from that graph. Now that we know what a, h, and k do, we should be able to do that. So here's our graph. We have our absolute value equation, so we know our parent function is y equals absolute value of x. But we need to put all the numbers in there. And so because we're being transformed, this could be equals to a in the front, x minus h plus k. So what are all those numbers going to be? Well, let me draw in our parent function with a different color here. Let's do red. So the v should be over here. Now what happened to that v? The first thing I see is the vertex of that v, this point, got moved over to here. So how did that move? Well, it went down all the way to -3. So it went down 3, and then it went all the way to the left 4. So our up and down was down 3. Well, up and down is controlled by k. And so as I'm going to start writing this equation, I know the very last number, the k, is going to have to be a -3 because we are going down 3. Let's put the absolute value marks in here. Put the x. Now it also went to the left 4, and h controls left and right. So this is going to have to be a 4. Now, is it plus 4 or is it minus 4? That's the next question you want to ask. So this is where we have to remember that h does the opposite of what it looks like. So in order to move left to the negative numbers, this has to be positive. A plus 4 will move us to the left. All right, now our a value in the front. First, I see this v is going up just like it should, so it has not been reflected. So this number will be positive. Now the stretch and the shrink are a little hard to see. So one thing I want you to notice here is that this equation is still going over 1, up 1, over 1, up 1, over 1, up 1. The slope hasn't really changed at all, so technically there is no stretch, so that is just a 1. And if you want, multiplying by 1 in the front doesn't actually change anything, so you can actually even just get rid of it. So there we have our equation. Y is equal to x, or absolute value of x plus 4 minus 3. Will give us our blue equation, our blue graph. Alright, so there we went from a graph to an equation based off of the transformation characteristics. Now let's try a different pairing. We're going to go from the equation and then write a description of it, just based off of the equation. So, what are all the characteristics we see here? We have f of x is equal to -2 times absolute value of x plus 3 minus 7. So first I see the negative. So that means f of x has been reflected over the x-axis. Alright, what else has happened? The 2. Well, we know that controls a stretch, so we have been stretched by 2. Now let's see, the 3. That is our side to side. So we've gone side to side 3. The plus means we went to the left. Remember, a slide is called a translation. So we were translated. Three units left. And the 7 The K there controls our up and down, and that one works the way you think it does. So the minus 7 translated us down 7. So we were translated 3 left and down 7. Those are all the things that happened to F. So we went from a equation to a verbal description of what happened there. All right, let's mix and match one more time here. What if I give you a description and then ask for an equation? So here we start out with h of x is equal to x minus 4. And we're going to do something. We're going to take that function h of x. First, we're going to translate it up 2, and then to the right 3. So that will change the numbers here. Now, if you think you can do that in your head, that's fine, but I'm going to show you some mathematical steps to get you to the answer that would work for a more complicated problem. So if we're going to change this function h, we're going to get a new equation. And if I have a new equation, I'm going to give it a new name. So I'm going to call this g. Since we're transforming it, we'll give it a new name. All right, now g of x, though, is going to be similar to h. But we are going to change h in a couple of ways. First, we're going to translate it up 2. Well, how do we move something up 2? We add a plus 2 on the outside. That's our k value. That moves us up 2. And if we want to go to the right 3, well, that's going to be on the inside. And if I'm going to go to the right, it has to be a minus 3. So this is just a it's a bad form of words, a translation of this verbal sentence. We're going to take the function h, translate it up 2 and to the right 3. But I actually want the numbers. What are the numbers for g of x? Something we could plug into a calculator and have it graph. Well, just like before in the very first video, we're going to take what's inside the parentheses and plug it in for x. So these two circles are going to swap. Instead of x, we are going to write x minus 3. So when we write h, instead of x, we're writing x minus 3. And then what happens in h? Then we minus 4. That comes after the circle. All right, so I wrote all of h down. And what comes after h? Plus 2. Now there's a lot of numbers there that we can simplify. So we will have x, a negative 3 and a negative 4 make negative 7, plus 2 is negative 5. Now you might have been able to do that in your head, but I think this step right here is really important for more complicated problems, which you'll be doing later on. So we now took this function h and did those transformations to it. We went from a description to an equation. All right, so I'd recommend practicing that a little bit. So here are a few practice problems for you that do all of those three things. Taking a graph, a description, and an equation, and going between all three.